In this video, I'm going to be going through the preliminary mid-course review, so the Year 11 HSC Engineering Studies mid-course review, or the Assessment Task 1 for 2021. There's 50 questions, 50 marks worth of questions. Which of the following is most correct? Concrete is made of cement and aggregates. Which of the following is not an alloy? So some of the aluminium, for example, can be an alloy, but all the others must be an alloy. So aluminium is correct. Which field is, so mechanical engineering is dynamic or moving forces. Which best describes the structural engineer, design structures to meet the needs of stakeholders? The others are all potentially true, but C is the one that is the most correct. Which of the following is glass? Glass is an amorphous solid. It's non-crystalline. Which of the following can be used to calculate stress? Stress is equal to force divided by area, A. Refractory means stable at high temperature. Which of the following is ionic bonds? It's the transfer of valence electrons. This drawing is an oblique drawing. Oblique means Latin for slanted. Pascals, well, so pressure and stress, they're the same thing, just different amounts. Strength is also measured in pascals. Power is the correct answer. Identify electrons have a negative charge. Hardness is the resistance to scratching. Brazing, brazing requires higher temperatures than soldering. All the others are incorrect. Which of the following describes plasticity? Ability to be deformed. Okay, for this one, it's 4.16 sine 60, which is C. Kids are saying C. Okay, the value of gravity on Earth is, Alicia would tell you, I keep on falling at 9.8 meters per second squared. I'm rushing this and my throat hurts, so I didn't do the song justice. Okay, which of the following relates to the first law? Mass is a measure of inertia. Yeah. I had to adjust that at the start of the exam because I wasn't entirely happy with it, but it's the one that most relates. This question, I said there would be one moment couple in the exam. This is pretty much taken from the examples in Copeland's book. The answer is 0.4, so if it's 0.4, it needs to be 40 millimeters. Polyurethane is the only thermosetting polymer in this list. The highest carbon content is cast iron with 4%. Okay. Moving on here. Okay, a crowbar is a lever, a screw is an inclined plane. I feel as that's pretty much a 50-50. As long as you knew the two, you know, most people were going to do okay. Time is measured in seconds. It is a scalar. Displacement is meters, and it is a vector. Weight or force. Force is the most correct, but weight is a force, so I gave it correct. Acceleration is a vector, and temperature measured in Kelvin is a scalar. Okay. I have this lever shown here. Now, I have several ways of solving this, which I've just gone through with my class on the board, but I'm going to give the briefest of summaries here. The first method is you can use the three-force method. You can find the point of concurrency. Once you find the point of concurrency, you can find the angle of reaction A. And once you find the angle of reaction A, you can then use the sine rule. Or you can just draw it to scale. There's different ways of solving it. The second method is you can find perpendicular distances. I found the perpendicular distance just using trigonometry. I've shown you that if this is 1300 and if that's 45. Another way is you can just measure it with a set square. Once you know that distance, you can then solve using the distance. The perpendicular distance is this purple value. D equals that number. Once you've got that value, so we saw that it was, this actually should be correctly in kilonewtons. I got that wrong, so sorry about that. Okay, so once we've done that, there's another way we can solve it. Again, this should be kilonewtons. Again, I'm sorry. What we've done here is we've instead replaced this 40 kilonewtons with two forces here that should both be 28.8 kilonewtons. Again, sorry. Okay, once you know the force, here I've corrected it. Once you know the force on F, there's using either of those two methods, you then find reaction A by finding the sum of the forces horizontally, the sum of the forces vertically. Once you know these, the two halves of A, the two components of A, RAH and RAV, what you can then do is use Pythagoras' theorem to find R, RA, and you can find the angle using the inverse of tan or arctan. Okay, so that's those questions. We can then move on to identify. So oxy welding doesn't require electricity. MIG uses a continuous feed, or some metal inert gas, uses a continuous feed of wire that an argon protects the weld. In historical order, we have bronze, then cast iron, then aluminium, then stainless. An example of rolling, I normally talk about train tracks or rails, but also a lot of people said sheet metal, which is true. I think there are a few other correct answers. Casting, people said quite a lot of different answers, things like pots and pans, which I guess is true. Garden taps is the classic example I was looking for, and engine blocks. They're the ones that we talked about in class. Okay. Polypropylene is used to make lunchboxes from this list. PVC is electrical cables. PET is disposable drink bottles. Okay. Identify an application of carbon fiber. A lot of people talked about racing and aviation. Those were the two examples we talked about in class. They're light and strong, but in order to justify it, I really wanted to a little bit more. Now, I just said light and strong. What I really want to see is carbon fiber has a good strength to weight ratio, or that it has good tensile strength or good stiffness or something along those lines. For the third mark, though, what is the easiest thing to do is if you said carbon fiber is used in racing because it's light and strong, and that makes it more fuel efficient, that allows the racer to go faster, right? Those sorts of things. If you say that, then that way, then that gives you the third mark. I think I was fairly generous. If you felt as though I wasn't generous to you, let me know, and maybe we can get you an extra mark. For the sketches, what I've been told to do is draw an orthogonal projection with a front, top, and side view of the object shown at a scale of 1 to 1. 1 to 1 means at the same size as what's drawn. I've said that it needs to be within 5 millimeters for accuracy, so that to the nearest 5 millimeters, which means that if you get a number that's like 34 millimeters, well, obviously it's supposed to be 35, but I can't get this, I can't print this on the paper that reliably because I'm not, a printing company. I'm just using a photocopier. So, I try to round the dimensions up to 5 millimeters. In this case, they've told us that this, I'm going to call that an S shape, is the front view. So the front view, does it specify third angle projection? We should do third angle projection because we use Australian standards in Australia, so which specifies or preferences third angle projection. So what we're going to do is we're going to draw that S shape down the bottom here. We're going to draw the top view on top, or the top view is on top of the front view in Australia. In France, it's the other way around where they use first angle projection. And then the side view is from this direction. If you walked around to the side, what would you see? Okay, so I've drawn that up pretty hastily, but I would still give this 3 marks. Even though it's been drawn freehand, it's close enough, dimensionally close enough. I did have one student who lost a mark because this line, the line that I'm showing here, was actually drawn there, and that's far enough off that I can take a mark off. If you drew the line down the bottom here, that would be the wrong side instead, so having an extra line there would lose you a mark. What else did I have? Some students didn't include that line on the top, and that would have lost them a mark. I had some students who drew this thing here. They knew the top view was on top, but they drew it at 90 degrees, which I like. So it was facing up that way, which I find, odd. But I guess that that's better that they at least knew that the top view goes on top. I think that's pretty much it. Some people didn't have them aligned, even though there was you clearly points to help you. There were people who just drew them in the middle of the page. That was pretty rare, given that I had the marks to help people. So most people got 3 marks. Some people got 2 marks, but very few people only got 1 mark. Your shape has to be pretty wonky for me to take a mark off. So if this was curved, for instance, I'd probably take a mark off. Okay, so the next drawing we're going to look at is this one. So this one here, we show the third angle projection symbol, which means that the top view is on top of the front view, and provide a pictorial sketch of the object shown below from the direction of the arrow. Take measurements drawn to the nearest mill. Oh, here we go. There's the arrow. Okay, so like we said before, the top view is on top of the front view. So this here is the front view. I had one student who drew it the wrong way, but he told me in the exam that he'd drawn the wrong thing, so I took it into account. I had one other student, and this is the first time I've used this exam before, so at least 50 people have seen this, and only one person's caught that this hidden detail line indicates that this shape, this hollow, goes all the way through, but the top view shows that there's something down here. There's some sort of object happening down here. Now, what that could mean is we could have, I thought about what is a possible alternative to this. What it could mean, without showing any hidden detail here on this side, is that there may be a sort of pyramid type shape, so that this is a big slant, it going in two separate directions, but that would give us on this face here a triangle. So there's probably something wrong up here. This part up here shouldn't be here, but the fact is, very few people, I've never really seen this be an issue, and the student who pointed it out, he drew the same thing as everyone else, which is this. So because that what's happening in the background there doesn't really show up to us, we're not really that interested. So yeah, like I said, that it's possible that we could have, this could be slanted and sort of slant here, and that would show a straight line without anything else. But it's really, it would be a better drawing if that part there was removed. So if you're looking at this for revision, know that I probably would remove that now if I was to reuse this question, but I don't think I'm going to reuse this question. So what does it look like? It looks like this. Now, I had at least one student, she lost a mark because she showed this shape here and this shape here, but because I couldn't tell the difference between her construction lines and her thick dark lines, I just didn't know what she was intending to draw, so I had to take a mark off. I think for a student who had this here, I was a little bit more lenient and I gave them that mark, but maybe it was because I was giving half a mark from somewhere else, which, you know, we don't really give half marks, but, you know. You can see I have construction lines, but they're in a different line width, so it's easier to tell what's going on. Okay.